mobile applications. We have interesting and exciting talks, and our first presenter is presenting over the internet. And Mustafa will be presenting analyzing remote server locations for personal data transfers in mobile applications.
Okay, very good. Okay, thank you. I can start. Well, with the other one. Okay. Analyzing remote server locations for personal data transfer in mobile apps. Mobile apps are everywhere these days. They are carrying a lot of information, personal information, and they're connected to internet. And mobile apps actually using this connection to collect personal information, transfer them to cloud, and provide better services. Cloud service provision is independent of location, independent of jurisdiction, and that's where their problem is coming. Because on the other hand, actually, different countries or unions have different jurisdiction regulations. Like as a use case, for example, European Union has regulations saying that in Article 25, for example, saying that personal data can only be transferred out of Europe when only an adequate level of protection is guaranteed. So we take this one as use case, and we provided a tool which is called PDT log in order to analyze mobile apps and measure the exposure of personal data to other jurisdictions. So there's a screenshot of the web interface of this app. Here, this tool, basically you can give an app to this tool, or there's another interface, you can give a bunch of apps and analyze that, and generates a report here saying that what type of personal data this particular app is collecting and where they actually transfer it. So let's have a closer look to this tool to see that how it basically works. So there are let's say, big modules, gross modules of this tool: static analysis, dynamic analysis, and location investigator. So this static analysis basically performs a code analysis, and we check reflection and dynamic code loading of the mobile apps. If they use such a thing, we run the dynamic analysis on the app too. And then we collect all the information and check the location investigator basically determines the location of servers. We give IP names or URLs we extracted from the code and from the running, and then provides the report. I just showed you an example of the report. So let's have a closer look to this module to see how they work. For the static analysis, we extract a smiley code, and we analyze the code in a backward manner. I mean, from source, we don't go from like source to sink, like typical things we have the state of the art. We go from sink to source, for example, because we have like just particular things we're looking for, and we go from sink to source. This is, in this way, we can filter out the other ways, because usually in these approaches, like the approaches that analyze the codes to see privacy leakage, they consider anything out of the app as a leakage. But here we just look for a particular case of that which transfer information somewhere from, which reads the information from the phone and go through the app and then transfer it to some server. We want to find the physical location of the server. So in this way, we go through the backward analysis and we analyze it in a backward manner. And the dynamic one, we actually use Android emulator. We install the app through ADB shell, and we stimulate the app with Monkey by sending random events to the app. And then we dump network traffic by TCP dump, and then analyze the network traffic to see what personal data is going through the network outside. And the whole thing is done automatically. In order to use our tool and use the European regulation as use case, we did a large scale analysis. We actually used the App Figures website, which provides statistical market information. We used it, and by the information they provide, we identified 400 top used apps in European countries. And collectively, there were almost 1,500 apps. And we run PDT lock on those apps. So what we identified, first, let's see what we found at what type of personal data they are collecting, these apps. We categorized personal data into 3 categories: content, which are the personal data provided or generated, let's say, by users, produced by users, and device, which are the information that generated by device, sensors, whatever device has, and network is the information related to network. On the left side, you see the chart. Actually, we put out the location because location. We see here like 75% of these apps, 71, I believe, of these apps actually collect the information provided by user, which is called content. And 67% of them network, almost all of them collect the information by sensors, device, the things provided by device, mainly device ID. And 75% collect the information related to location. They want to, and many of them, they want precise location, to know where user is located right now. And where they actually transferred, we identified the servers that are targeted by these apps, the servers they transfer information to. And this is the surprising results we got. Only 23% of these servers are located in Europe. The rest of them all around the globe. To have a closer look at these servers, we did we showed this chart here. We have actually 2 types of, as I showed, we have static analysis and dynamic analysis both. So the results by static analysis, we call it potential data transfer because we analyze the code. We don't really actually run the code. We analyze the code and we figure out this app is collecting this information and transfer it to that server. So we call it potential because it's in a legal terms, we cannot really claim it. But the observed one is the outcome of the dynamic analysis. Dynamic analysis, actually, we run the app and we check the outgoing traffic and we observe that personal data in the outgoing traffic going to a particular server. And the dashed one are the observed one. For example, here we see that like almost all the apps, I would say, I think all of them, not all of them transfer information to US, but we observed 258 of them transfer to some servers located in the US, 10 of them in China, 6 in Japan, 5 in Russia, and so on. We see that these apps, clearly they violate European regulations, European data protection regulations related to the jurisdiction. These are, we can claim it. The potentials, yes, we need more investigation. And we did, to show the gravity of problem, we did a privacy policy and analysis on privacy policy. This is not what our tool does, but we did it separately. So surprisingly, these popular apps, these are the apps used in Europe. Most of people use it, and I believe these are the apps used in the rest of the world as well. They must be popular in the rest of the world as well. Almost, actually half of them, 51% of them do not provide privacy policy at all. They do not say what kind of personal data they collect from users, why they collect it, where they transfer it, and what they do with that information. And out of these 51, almost all of them, like 50%, they transfer information. Potentially, we found that they transfer information out of Europe. And 7% of them, we observed the information transfer. And the other half, which provide privacy policy, 49%, all of them potentially transfer information out of Europe. 13% we observed that they transfer personal data out of Europe. And 9.5% out of this 13, they are actually transferring to the United States. So, and this work actually got some attention because of this alarming result. One newspaper in Italy, and we had an interview with CNIL in France, and they wrote an article about it, which is available. And they're going to use the tool. They asked us, we are going to use the tool. We are now talking to SAP because SAP is the one who actually owned our work, this project. So SAP can decide that if we can release it as open source or not. Thank you for this. You can see the rest of the, actually the more details of analyzed apps in this URL. You can have it. If we have some time, I can show you a little demo of the work. How much time left? Okay, so let me show like 1 minute of demo. Okay, here I'm showing you, this is like basically how it works in reality, the tool. We search an app, we find it, like for example, this app. Then we can simply copy the URL of Google, go here, like paste it, then start. And it downloads the app itself automatically here, and then performs 3 types of analysis. Basically, the one demo I'm showing you is another version after what we presented in the paper. It's a one about a bit more advanced. And of course, it's not that much quick. I just fast forward the video. And then when also this dynamic analysis is like this. This is recording from server. It installs the app itself and then sends events to the app. Actually try to trigger the app by entering some input like pressing buttons and things. And then at the same time, we monitor the behavior of the app to see what it's collecting and where it's transferring the information. So now let me put it fast forward. Yeah, the analysis, then finding the location of servers here. And then, yeah, this version actually extracts the hard-coded URLs as well. It provides very detailed information of the type of analysis. Here you see we have a static, dynamic, and hard-coded URLs, and down we have the type of personal data information collected by static analysis and dynamic analysis in different categories. We can click on them, see more details of this, and yeah, it provides a lot of details to analyze the app more. Here we have observed transfer information, and we see that what actually we observe. We are sure that the app is collecting this information by dynamic analysis. We are sure that transferring there, and like there and down, we have some maps, okay, showing that where it's going. Okay, I think, let me put it here if somebody wants to see the URLs. Okay, thank you everybody. If there's a question, I'll be happy to answer.